just not gonna have this up because I can't connect to it anyway. And let's just start with Gitra. Okay, so first of all, that's safe. And so first let's just like analyze the binary just so we know what's going on with it. So just throw in some PLT tables and some GOT tables. So that's my app. Yes. Okay. So in our PLT table, we see that like it hasn't called too many functions, but it has called puts, it has called system, and it has called printf, right? And we also know that it has called gets, right? So we know that at least these functions have been called, right? Now, when people see puts in system, they usually go for read to libc, but I'm not going to do that because that is way too complicated for me, and I hate read to libc. So we will start with the simplest thing. First off, let's try and break it and see how this program breaks. So so the input mechanism in this program is going to be a little different than what it was before, because it has stuff at the start of it. So let's first pass in 1024 just because we know for a fact that's going to break it. And let's break it and see what happens. What is exploit new? Oh, shall exploit new. What the fuck? Safe.py, that makes sense. Alright, write for doesn't exist because we are trying to write for. What am I? So, okay, so obviously in the pawn process you need to have the binary that is executable. We are starting off this at a great note. Okay, so now that we're still... God, I hate... I'm sorry, it's been a long day. Okay, now, beautiful. Hey, so we know that it's a ROP. We have stopped a return pointer. We have control of the saved return pointer. We also have control of RSP and RBP, and we have control of RSI. Sadly, I don't see any control of RDI, which might be a problem, but we might have some ROP gadgets to fix that, like we did in the one before, right? So let me go back to this, and then let's see exactly what offset we're looking at. Come on. Okay, beautiful. So we know that the saved return pointer is at this address, but the one thing that I did do, because we know that my app is a 64-bit executable, so just for memory's sake, let's make that n equals 8 and then make it repeat every 8 times. Debrusion loves that. This is only because we know it's a 64-bit. And there you go. Okay, so now, okay, so we know that our save return pointer is stored right here. So we can just make a new offsets column, and we can say offset save red ptr, and that can be there you go. Oh my god, bro. I cannot type. Okay, so now that we have this, we have now control over the save return pointer. But let's see, do we need control of anything else for this? No. I don't think so. Okay, beautiful. So now that we know we have control of the state of return pointer, let's just test. Make sure we're good. And zip on. And just for good measure, just so we do this later in lab also. Okay, so at this point, whatever we add to the next line should be the next saved return pointer. So this has a bunch of Z's, and let's run this. And there you go. We have a bunch of small Z's on the saved return. So currently we have full control of our saved return pointer, and that is beautiful. But here's what we need to do, okay? Here's what I am trying to do in order to get shell with this, okay? So what we're going to do is, let me just nano something new. I don't have nano, of course. Okay, so here's what I'm trying to do. Here's my steps. So step one, all right? So we have already verified that we have gets on this. So rabin2-r my app, and we have already verified that we have at least the global offset pointer of gets, right? So if you look at what gets does, if you man gets, you can see that gets takes a string from standard in, which is really nice for us. And like it only takes one argument, so this argument is going to be stored in which pointer? RDI, because of the very first argument, just like the previous exercise. So if we are able to populate RDI with a pointer to a certain memory location, then we can give this program any input that we want, and that input will be stored at the memory location pointed by us. So using this, we can write to a certain memory location. Does this make sense? Let me make it a little better. Okay, so firstly, we identify a memory to write to. So when I say identify, I mean this location has to be, so it has to be, first of all, it has to be, okay, it has to be writable, obviously. Also, it has to be non-random, so not affected by ASLR, right? So we know exactly where the memory location is, and we can write to it. So once we identify such a memory location, we know that gets, which is takes a char star S, and so this S that you can see here, this can be this memory location. So let's call the location, um, I don't know, writable. Okay, so the name of this variable, okay, writable, yeah. And so if we put writable in here and we call gets with writable, that means so to do this, we have to first pop RDI, all right, pop RDI ret, and then put in the string the location of writable, so star writable, and then after this C, we call the actual address of get. So call gets from global offset table. All right, does this make sense? Okay, so once we do this, we have successfully run get. Oh, sorry, gets the method gets. Now what gets does, as we see from the man page, is it takes input from standard in. So standard in is basically the keyboard, right? What you type, the terminal. And so we can give it our own input. And this input that we give it, we are going to use that input to smash another stack. Does this make sense? It's a little confusing, I understand, but does this make sense? Huh? Yeah. Okay. Because, okay, so theoretically speaking, you are calling gets and gets has its own stack frame. And so we are going to smash this second stack frame also. So it's kind of like a ROPception. We're doing a ROP inside a ROP. Okay. So once we have done this, right? Once we've done this, after step 2, right here, we can be assured two things. We can be assured that at memory location writable, we have a string that we wrote. Yes. So we can be assured of that, right? Now here's where it gets interesting. So once we have that, we can yet again call system with writable. Because what if at writable we wrote the string sure and then escaped it, obviously. There. We wrote that string. So if we wrote that string, as we've seen before, this gives us a reverse shell, right? And if we call system with this, it gives us a reverse shell. So how do we call system with this? So first of all, pop RDI, return. Second, um, so what do we want to put into RDI? Again, this memory address of writable. What? Yeah. And then after that, we call system from PLT, GOT, whatever. We have options for that. Okay. So this is going to be our game plan. Okay. Exactly. Exactly. Yes. Okay. So let's first identify what is a writable section of memory. Okay. So most whatevers have, so I know like a lot, like I know IDA and have a section that you can see is writable or not. I do not know how to do it in Ghidra, but I do know that .data and .bss, these are two writable sections of memory. This I know. How I know this is, I don't know, I've just done reverse engineering in my life. So I just know this, okay? And yeah, exactly. I just know it from my experience. And so as you can see, .data has nothing in it, but also it's not too big. It starts at like 47 and ends at 38. That's eh. .bss on the other hand has nothing in it. It starts at 4f, ends at 48, and we can easily put sure inside that part of memory. Correct? So let us choose a part of memory, and I'm going to cheat because like I've already chosen a part of memory, so I'm going to use 4a because 4a is the, oh my god, why can't I call? Okay, because 4a I know is writable and 4a is also easy to access and easy to remember, because if you can see 4a would be this. So I'm choosing this part of memory right here in order to write to. Okay. Oh my god. Okay. So let's make a new pointers tab. str writable. Why do I do this to myself? Okay, and so that is our writable part of memory. So we have currently identified a memory location to write to. This is really good. Now we have to call gets. Okay, so that is what we're going to do. We're going to call gets. So to call gets, we need to know where gets is located. Oh my god. We need to know where gets is located. How we do that is global offset table and PLT. So you see, you know that gets is located at that memory location right there, correct? Let's take that and add this here. Pointer to gets equals that. Okay. So for now, let's just use this to make our oh, also we need a Rob gadget. I completely forgot about that. So the way we get Rob gadget opt Ropper Ropper. Okay. And then the file that we're going to give it is my app. Right. So these are all our Rob gadgets. Let me save that into a file. Into my gadgets. And now that so now let's, yes I can. It looks pretty shit. Wait, let me try and make it better. Give me 1 second. I can give you 720p because everything after that is paid and I'm not good for it. Is it better? Yeah? Okay. Okay, beautiful. So, okay, so currently we're trying to identify a Rob gadget, yes? Now what Rob gadget do we, what Rob gadget do we want? Right, so basically pop RDI, right? So let me grab for RDI and let's see what we get. Nothing. Nothing. This is beautiful. Okay, so Ropper isn't currently giving me anything for RDI. What if I do that? What if pop RDI? Nothing? Hmm. I see a pop. What? Okay, it's probably because of the color. Okay, it's probably because of the color. But you can clearly see there's a prop RDI red. Right here, right? I guess there's a way to make it no color, but I'm not going to go into that right now because I don't put it. So we will do pop RDI red and throw it in there. Those are our gadgets. Uh, all right, beautiful. So we have that gadget. Let's also remove this shit. Okay, so we have that gadget, which is a nice gadget. It's pop RDI, right? It gives us full control of RDI. So currently, let's just call gets, right? Because that's what we want to do. So how would you call gets? What do I do first? Okay, but before I call gets, like I need to set up my registers, right? So my only register that I need to set up is RDI, correct? So if I pop RDI and then put in the pointer to variable there, that I should be good. That should be it. From there, I can just call gets and I should be good. So currently I'm going to throw in the gadget RDI control. And okay. And so that's going to pop RDI for me. You get it? Alright. And then we throw in the pointer to writable. And so that's what RDI is going to become. And then buff plus equals. Now now we make a call to gets. Beautiful. And there you go. That's gets right there. And this ROP chain right here that we created, this should call gets with um one argument, and that argument is our pointer to whatever writable memory location we just found. Right. So I want to breakpoint. So give me 1 sec. Let me just find where this code breaks so I can breakpoint it. Oh, stop. Where? Okay. All right. So right here. So I can breakpoint right there. Yeah. Because I want to find the address of the return instruction that it's breaking on. And so once I know what part of code that I am screwing around with, I can just put a breakpoint on that and then it should be good. Okay, beautiful. Does this make sense? Until now. Okay, beautiful. So let me run this. Okay, so we are at our breakpoint. And so we see first our ROP gadget to pop RDI. So that's on there first. And the next thing that we're putting there is a writable memory location that is currently 0. So if I do next, it pops RDI, and you see RDI is now our writable memory location. And that writable memory location currently has a value of 0. Okay? And then after this, we go into libc, we do gets, we do a lot of libc bullshit that we don't want to fuck with. It just gives you a seg fault currently. But let's fix that. So now that we have called gets, this right here is stage 1. Yes? Beautiful. So we're done with stage 1. So stage 1 calls gets with a pointer to a writable memory location that we can now control. And how we control that is stage 2. And the way that works is, let me just call it stdin, just a new variable. So currently what we've done is we've called gets, right? And what gets does is it takes an input from stdin, and that stdin input is what we are going to start providing now. So we are going to start by crafting our own stdin. Okay. So let's try and smash that stack again. And there you go. So now when we smash the stack, oh my god, we hit the breakpoint. Can I not do the breakpoint? Can I remove the breakpoint? Is that okay? Just for now. Okay, good. We receive a seg fault at some place for some reason. Okay, that should not have happened. See, that's why I have my own code up so I can go back and see where I ended up. What the fuck am I doing? Oh, this is the one. I've been looking at the wrong exploit the whole time. I'm sorry. Um, this is the one that doesn't work. This is the one that's really complicated. This is the one that does work though. Okay, much better. Um, so stage one is, so I'm popping RDI, putting up under doing gets. What the fuck? That's what I've been doing. What the fuck does it want from me? Okay, so I'll tell you what. Let me just code in all, so the whole like stage one, stage two, everything, and then we make sense of it because I think it's breaking right now because I'm not providing it the right in. Okay. Okay. So currently, let me see if they have the right gadgets too. Pointer to gets is, I have, for some reason, I have a different pointer to gets over here because I didn't have gets in my PLT. Okay, let's go back to Gidra and find where exactly this is because I had just one gets. Oh, there are, okay, obviously. So this is the pointer to gets in the PLT. Okay. So now, okay, so the PLT, as I said last time, the PLT, if ASLR is off, the PLT is not going to be affected by memory changes and all of that shit. So if you call the PLT gets, like if you can call a PLT function, call the PLT function because it's a lot easier than calling the global offset table function. Okay. So the pointer to gets is, obviously I just copied it right now. And for some reason, I have a pointer to random writable memory, which is before. Okay, so let's do this again with what I have right now. And this should work. So I have get, I have std. Is someone writing something on Discord? We're trying to record. Anyway, so we have a pointer to get right here. Pointer to memory. And pointer to pop RDM. I'm just going to really quick check if that's what I did. Yes, that's exactly what it is. Okay. So let's try this again. See if this works. All right, beautiful. It does work. This is nice. So it does work. And right now, if I x-sw to xw, I think, and if I try and find what's in writable memory, this right here, See, I have a bunch of A's. So that means I have successfully written a lot of A's into the pointer writable memory. Does that make sense? Is there like, sorry, that's the basic concept of what we're doing. Does the concept make sense? Yes? Okay, beautiful. So from here, now that we have some like a tangible memory location for it, what we can do is we can just throw in sure into memory. So sure, of course, escape it. I'm sorry. Um, yeah. So if you put who the fuck is calling? So we can escape it right there, and that is sure. Now there is another function called ljust, which just so it adds padding of null pointers, so you don't have to do this backing. So I have used that here, right here, because so in 64-bit coding, right, it's always good to let the the computer do all the work for you so that you can do the least amount of work. So this right here, what this does, this generates the same thing as, so it generates a string like this. So it does sure, and then it escapes it, and then it escapes it. It keeps doing that until it reaches e- eight, like 8 bytes. Does that make sense? Yeah. Okay. So then it just writes it to memory like that. So currently we are sending sure into memory, and at that place, at that exact spot, we should have the word sure. So if we run this right now, and if we, I didn't save it, of course I didn't save it. So if we run this right now, we can see we have the word sure in a tangible memory location, right? Does this make sense? This is huge. So from now, we can easily pop a shell. So what do we need to do to pop a shell? What? I can't hear you, sir. Yeah, but like with what function? With what function? Exactly. It's a system call. Exactly. So we can do this whole pop RDI shit again. And I don't know why I didn't change this variable. And we can do this whole thing all over again. Bro, this is just dumb. Technically, this is stage 2. So let me put that in there. Okay, so this is our stage 2. So currently, we're going to pop RDI, we're going to put in our writable memory into RDI, and then we're going to call system. So we need to know where system is. And to do that, we are going to use the PLT table, find system, and PTR system equals that shit. Okay, and now all we have to do is call PTR system. Hopefully, this works the first time around. Let me remove the debugger. Okay, I'm going to remove GDB because, so do you want me to add a breakpoint just for you to see exactly what happens? Okay. Okay. Cool. I'll do that. So we hit our breakpoint, right? And at the breakpoint, we're going to pop RDI and we're going to do all of that. And inside RDI, we're going to put our writable memory location, which is currently 0. So boom, boom. Okay. So after that, we do gets. Now, I don't know how far we can go into gets, but I'm just going to next my way. I think that's done. I'm going to guess that's gets. Please. Okay, but okay. So you understand how like gets uses, so we use gets to put sure into memory, right? Okay, so I'm going to remove the debugger now. First off, remove the breakpoint and then remove the debugger complete. Remove the GDB attachment completely, and then let's run this and see what it gives us. So something, it gives us something. Hopefully if I do ID, hey, root, hey, hell yeah, we just dropped shells. Does this make sense? Do you have any questions? Yeah, no, go ahead, go ahead. Yes, yes. Well, so when I say different types of ROPs, I mean you have to use the ROP gadgets and like tools available to you to like develop this. Once you have this plan down, ROP isn't hard, but you have to make this plan. And that's where the difference lies. So no, right now the program itself has ASLR disabled. So if I put my debugger back on and if I have the breakpoint on, I can show you that the program itself, check that. The program itself has NX enabled, but has Pi, that's ASLR, disabled. And so in this current program, you didn't have to worry about ASLR. But if you ever do have to worry about ASLR, um, then you have to like leak memory using puts and all of that. It's a long process, but like that's where Google comes in. You have to go and search and shit. Yeah, yeah, I can try. But like it's really hard. Like that's how like you do a red to libc attack. In the future I can teach you. Yeah. Yeah. Okay, so if you just go to Rob Emporium, robemporium.com, spelled Rob Emporium, how it's spelled. So they have challenges and it's top down, left, right. And so first you do red to win, then you do split, then you do call me and right for. And like, so these challenges are basically exactly what you need to do this stuff. Yeah, yeah, yep, yep. But this is how you practice it. There are a few other links to a few other people, but like I recommend if you just do Rop Emporium, you should be good. Yeah, so okay, so the tools I used were okay, so one of them was obviously Pawn Tools. It's a Python script. It's like I think you can pip install, should be able to pip install. And then the other one is Ropper, which again you should be able to GitHub it. You should be able to GitHub it. The third one is PETA. PETA is again PETA's not exactly a tool, but it's I used it, so I'm just gonna put it down there. It's you can GitHub PETA too. What else did I use? Rabin 2. Rabin 2. So Rabin, if you're using Kali, Rabin 2 comes pre-installed. But I know they have a GitHub page. I used Gidra also. Gidra, you just Google that shit. And I think that's it. Oh, you want to upload this on YouTube? My contact, I don't have I don't have a YouTube channel. I don't have an uh so I think my Discord is that that let me go down. Yeah, no, but there's an Abiza in front of it. Yeah. So it's hashtag 9042. Yeah, yeah. So if you have any other questions, shoot. Not really.
No, no, no.
No? Alright. Alright. GG's. If you want this code, I mean if you want the code to like actually like get safe done and hack safe,